MapReduce examples. Example 1, word count using MapReduce. So, here we see the structure of map and reduce program, which will do the word count in a given document. So, the input we assume is a document with a name is given as the key, and the text of that document is the value. For each word W which appears in a particular text of a document, this map will emit that name of that word and the value 1. Now, this particular intermediate results, that is the word and this value is taken as an input in the reduce function. So, reduce will get a key as a word which is emitted by the map function, and the values as an iterator over the counts. So, the counts which is emitted by the map function as the value, and here also this word is output by the map emit. Now, this iterator will run on this count values. So, for example, for each count value v in the values, it will do the sum, and for every key it will result the output. Let us see this illustration through this running example. Now, in this example we consider a document, let us say this name of a document doc file, and this is the text of the document. Now, when this particular name of the document is given and the text is given, so these particular text words as it is appearing, it will emit word and W. So, here we see that W and this is the value 1. And this is the value. So, as these words are appearing out of this particular text, this map function will emit these W and 1 out of this particular previous program. So, after this emit of these words, it will do a shuffle. In shuffle, what it will do, the same words it will try to collect together, it will sort them and collect them together and then pass on. This is the shuffle phase, and then pass on to the reducer phase. Now, it depends upon how many reducers we have. Let us assume we have 1 and 2 different reducers. So, as far as this Bob is concerned, it will be passed on over here, this will pass on over here, Bob will go to this particular function, run will go to this particular function, to this reducer. I spot will go here, and throw will go here, and this reducer will now for example, in C there are 2 different these values. When it comes and iterator, it will go through this iterator function and make the summation of it. Now, let us see another example, example number 2, counting words of different length. So, in a given document we have to find out the documents of a given length. For example, this is my pen. So, here you see that this word is of length 4, this word is of length 2, this word is of length 2, this word is of length 3. So, counting the words of different length is, you see this particular word of length 2 is appearing 2 times, the word of length 4 is appearing 1 times, word of length 3 is appearing 1 times. This we have to give as an output for a given document file. So, let us see how map and reduce function is utilized to do this particular job. Now, to do this counting words of different lengths, we have to design the map and reduce function. So, given this particular document, the map function will emit the key and the value. So, the key comprises of the length of a word and the word itself. So, for example, THE, this is the word, this will be emitted and also the length will be emitted. So, key value pair will be the length here, length of a word, and the word itself will become the value. This will be emitted out of the map function. Now, after that, what the reducer will do, reducer will accept this format, and then it will be grouped by so the reducer will now collect the key and corresponding it will outcome the list of the words. So, for example, here you can see the word of length 3 is 3 different words which are appearing is being clubbed together as a list. So, this will be the output of the reduce function. So, the reductions can be done in parallel, again providing a huge advantage. We can then look at these final results and see that there were only 2 words of length 5 in the corpus and only 2 words of length 8 and so on. So, this we have seen through an example that using MapReduce program, complex program or application can be easily programmed, and this is going to be used in a big data applications. Example number 3, here we have to find out the word length histogram, and if this particular document is given, and then what we have to find out that how many big, medium and small words are appearing in this particular document, and this becomes the word length histogram. For example, that if the words of length, that is 10 plus letters, we say that this is the big word, and if let us say that document, if a word is having 5 to 9 letters, then it is a medium word, and if the word is having 2 to 4 letters, then it is a small word, and if it is the word of single letter is called a tiny word. And instead of doing this, let us color these words with yellow if it is big word, red if it is medium, blue it is pink, and blue if it is small, and pink if it is tiny. So, given this particular document, if we color them according to this word length categorization, so the document will look like in this manner. Now, we have to find out the word length histogram. Now, to do this, you know that in MapReduce program we can divide this entire document into the chunks. Let us assume that this is upper this portion of a document is chunk 1, the other portion, the remaining portion is chunk 2. So, we divide into 2 chunks, and now we have to write down the map function. So, map function will be based on this word count application, wherein if a word is given and the map function will take the key and the value. So, key will be this document and this value will be these words out of this particular document is written. Now, whenever a word is there, then through this particular length we have to find out whether it will emit, whether it is the color of a word and one will be emitted. Similarly, as far as the reduce function is concerned, reduce for every key it will make a sum of a count and it will do the aggregation. So, count means the iterator will make the sum and this will be the output. So, in this the chunk 1 will emit this statistics, that is yellow 17 different times it is appearing, red 77, blue 107 and pink is 3. Similarly, the map task 2 will emit the yellow as 20, red as 71 and blue as 93. So, these numbers are internally done, that means at every task the reduce function is applied, that is why instead of 17 times once it is doing this. Now, this reduce again will combine them and give the final outcome, that yellow is 37 and red is 148 and blue is 200 and this pink is 9. So, if we see these different steps, so this step is called a shuffle step, and through this different 17 and 20 here there will be an iterator and this reduce function will now add after going through this iterator and these values will be outcome. So, this example shows the word length histogram, which is nothing but an extension of word count program. Now, there is another example 4 to build an inverted index. So, by mean inverted index is, for example, if a document is given or a set of documents is given, then we want to find out the text or a particular word which is appearing in a particular document, and then we will finally collect a word which is appearing in all list of all documents where it is appearing. This is called inverted index, and search engines are now using this concept. So, let us see how this happens. So, map function will take a key value pair and will emit the name of the word, that is called value, word value, and the document ID it will emit. So, for example, in this particular case, here the word like pancakes, it will emit the document ID, that is 2eat1, and it will again emit, let us say, a breakfast, this is 2eat1. Similarly, in the next one is called pancakes, 2eat2, and then in the next one breakfast, 2eat3, and here eat, then 2eat3, then love, then 2eat3. Now, this is an intermediate key value pairs which is emitted by the map function. Now, using this we have to find out the inverted index, that is the desired output. Inverted index by mean that the reduce function will group by keys and will list out all that particular document IDs where it is appearing. So, the reduce will basically emit the output as these words and the list of document IDs. So, therefore, in this case pancake, if you see, is appearing in this tweet 1, is appearing in this pancake is appearing in tweet 1, and also the pancake is appearing in tweet 2. Similarly, the breakfast, if you see, is appearing in tweet 1, and the breakfast is also appearing in tweet 3. Similarly, eat is appearing in tweet 3 and also in tweet 4. Love is appearing in tweet 1 and tweet 4. So, this will form the inverted index using simple MapReduce program, and whenever a search engine uses the word breakfast for searching. So, it will give these two documents, tweet 1 and tweet 3, where this breakfast was being referred in that document. Now, we will see the operations, how we are going to perform the relational join operation using MapReduce. By relational join, let us understand this example, and then we will see how that is done using MapReduce. Let us say that employee is a table having the attributes as a name and its SSN number. Similarly, another document which is called assign departments, here we have employee SSN and the department name. Now, if you want to join on employee and assign departments, if we want to join on SSN equal employee SSN, then we see that this particular employee with the name Sue has a matching employee SSN with the accounts. So, if we join them, this particular tuple will be generated. What about the other one here? This SSN has two matches. So, therefore, this particular tuple, two different tuples will be generated accordingly, wherein this is the sales and marketing will be reflected. Now, let us see how this we are going to achieve using MapReduce operation. Now, before going into details, we have to understand that map and MapReduce is a unary operation, and this join is a binary operation, wherein it requires two tables, table 1 and table 2. So, how this MapReduce, which is a unary operation, will be used to do a relational join, and that we have to see that. Now, what we will do is we consider the entries or the tuples of the table as a single tuples, as the collection of all the tuples, and we will attach this identity of the name of a table also. So, it becomes a key value pair. So, key value pair means that the name of the table will become, let us say, key, and the remaining tuple will become the value. This way we will list out all the tuples which are there in different table. Now, if this becomes a complete data set, then we can perform the join operation easily. How the join is happening is around a particular key. So, around a SSN number. So, SSN number will become the key here in this case, and we will emit the MapReduce will emit the key and the value. So, key will be this SSN number and the value it will emit will be the entire tuple. So, now as far as the reduce is concerned, reduce will now group by this key, and then after group by key, then it will try to do the iterator, and if these table IDs are different, then it will make a join operation within it. So, let us see here in this case, as I told you that we have to decide what is the key and what is the value. So, key will be the SSN number around which we are going to join. So, whatever is the join becomes the key, and the entire tuple including the name of the table or name of the document as, and all the tuple will be that value. So, this after finding out this kind of things, then now we have to do a join operation. So, in the join we will see that when we make a group by key, let us say that two different tuples are appearing, and since their tables are different, so we are going to join them using these different notions. And similarly, here in the other case, we have a employee and two different departments. So, this employee will be joined. So, it will generate two different tuples, wherein the Tony and sales is one tuple, Tony and marketing will be another tuple. This way the join operation, relational join, we can perform. Now, if you take another example, let us say that we have two different tables. One is the order table, the other is line item table, and their tuples are listed over here. Then with the map function, what we will do is, so we have to join around order ID. If we are going to join around order ID, so order ID will become the key. So, the map will emit the key and the corresponding all the values, that is the name of the table and the corresponding. So, for both the tables it will generate this will emit out of the map function. Then the reducer will combine by this one key. So, it will group by key, for example, this order. For example, key number 1 is appearing 3 times. So, one with the order, the other is with the line. Now, then we are going to combine this order with two different lines. So, basically it will generate two different tuples, which is shown over here. So, by this example we have shown that using MapReduce we can perform the relational join. Example number 6 for finding the common friends. So, this kind of finding friends is very common in the social networks like Facebook. So, Facebook has a list of friends, and we want to find out the list of common friends which are there in the social network like Facebook. Now, this kind of operation of finding common friends is quite common when you visit someone's profile and see the list of friends that you have the common. This list does not change frequently, and but it has to be calculated at a regular intervals using Facebook. So, let us see that how using MapReduce we are going to perform this kind of operation. So, assume that the friends are stored in this format, for example, a person and the list of all the friends is basically given as the input. For example, person A is having a list of friends B, C, D, similarly B is having A, C, D, E, E, and so on. So, the person and arrow followed by the list of friends is given as the input to this particular program. Now then we will see that how to find out a common friend is, first thing is, for a map function what we will do is, so if the person A and all the list of common friends is given. So, we are going to generate a tuple that is of A B, then A C, then A D, and we will output the same set of list, that is B C D, B C D, then B C D. Similarly, for another case also with B we have B A, then B C, then B D and B E, and all these same tuple will be generated, that is in the form of a key value pair by the map function. And finally, the next thing has to be done by the reducer. So, reducer will find out, reducer will reduce a group by key. For example, A B is a key and it has two different such list which has been obtained, and so now similarly for a key A C, two different list and so on. So, once this is obtained, so reducer will find out by taking the intersection of these list of values, and that becomes the list of common friends. For example, A B has two different lists, A C D E and B C D. So, if we take the intersection which is common is C D is appearing in both the list, hence the list of common friends between A and B is C D. Now, this operation will be performed in this particular manner by finding the intersection, and for every set of persons. Now, in this manner we is computing the list of common friends in parallel, and this particular operation is being performed. Thank you.